Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, we will discuss question number 6 of NEET Physics 2014 paper. Hello students, let us solve the next question. This question is number 6. It talks about a balloon with mass m. A balloon with mass m is descending down with an acceleration a. So there is a balloon of mass m is descending with an acceleration a. A is less than g. That is also given that a is less than g. How much mass must be removed from it? So how much mass you withdraw from this balloon so that it starts moving up with an acceleration a, the same acceleration a. That means the balloon which is supposed to be moving down with an acceleration a, you have to make it to move up with the same acceleration a. To do that, you have to reduce some mass or remove some mass from the balloon. So that is the question, how much mass is to be removed from the balloon. This is a very simple question. First of all, you have to draw a free body diagram. Once you draw a free body diagram, your answer will automatically come out. So this is the first situation where the balloon is moving down. This scenario is for the case when the balloon is moving up with an acceleration. Now, let's say in this situation, the force diagram will be, this is mass of the balloon and g, that is the one force, that is the gravitational force acting downward, and some buoyancy force will be, or of thrust, will be acting in the upward direction. The net force on this object is mass into acceleration. So I'll write that because this is more, so mg minus f is m into a. Okay, this is one equation that I'll write. In the second case, this balloon has to move up, but some mass is removed. I have removed a mass, suppose that is m dash is the mass that is removed. So what is the mass left now is m minus m dash. This is the mass of the balloon. If I draw a force diagram, the gravitational force acting downward will be m minus m prime g. Because it's moving down, because it has to move off, so that gravitational force will be also down because this is moving up. So the thrust force will be in this direction because earlier it was thrust force acting, but actually what is happening is that in this situation, that when it is descending, I start removing certain masses. In that situation, the downward force will be smaller and upward force will be greater, and because of that it will move off. So this force is upward and this force is downward, but this now, because of removal of this mass, this force is lesser than this force, this is greater than this, the difference produces the acceleration of this. So difference in mass of this is the acceleration. So I will write for this that F minus this one is mass into acceleration. This is equation number 2. Now you have these two equations and you have to solve it. So we don't want f, so I add these two equations. This f will eliminate, and the remaining we have to write it down and simplify. Let us now add these two equations. You have these two equations. You have to eliminate this f by adding these two equations. So add 1 and 2, and what you will get, mg minus f is m times a, the first equation. The second equation was just moving up, so f minus m prime g is m minus m prime into a, because it is moving up. If I add these two equations, what I will have, this force will cancel out, and this equation becomes mg minus, if I open bracket and write down, this will become minus mg. This minus plus, so it is plus m prime g. G is multiplied to both the terms. This equals to, this ma is there, plus this one. If I open the bracket, this is ma minus m prime a. So from here, I will have whatever that will cancel out is this one. I am interested in m prime, so I bring this term to this side and take common m prime, so it will become m prime common, g is there, and this minus will come to this side, becomes plus, so a will be left behind. And the right side we have ma plus ma, that is 2 m. So from here I am getting m prime equals to 2ma divided by g plus a. So this is the m prime, that is the, what is m prime? That our aim was to find m prime, and which was the mass removed from the balloon so that it will accelerate upwards with an acceleration a. So this is the correct answer to this question, and therefore option number 1 is correct. 2ma over g plus a, 2ma over g plus a. Okay, thank you.